Pre-Calc, Section 7.2, Part 5, Hyperbolas with center HK. This is our formula for the horizontal hyperbola with center HK. Very similar to what we looked at in the previous video. It's just now that we have a center HK rather than 0, 0. Remember, with the hyperbola, what we're looking at to decide if it's horizontal or vertical is if x or y comes first. Because x comes first, it is a horizontal hyperbola. It has nothing to do with the size of the denominators. To find c, we use the formula a squared plus b squared equals c squared, like Pythagorean theorem. So the center is hk. The horizontal axis is the transverse axis, which is the fancy word for major axis. The foci are found by adding the c value onto the h value. Because it is a horizontal hyperbola, everything is going to be done to the h part of the center. So the foci will be h plus or minus c, comma, k. The foci are on the transverse axis. To find your vertices, you're going to add a onto the h value. And we end up with h plus or minus a, comma, k. The reason it's a is because this is a horizontal hyperbola. Therefore, we use a, which is our horizontal component. And the vertices are always on the transverse axis. So the foci and the vertices are on the same axis. They are on the major axis. Specifically, they are on the horizontal axis because it is a horizontal hyperbola. Now here, this is a little different than the last video. We're only going to talk about the slope of the asymptote. So I'm not going to ask you for the whole equation of the asymptote. We're just looking for the slope. The slope is found by plus or minus b over a. So let's take a look at the vertical. It's the same situation, but now we have the y being in front. That's what tells us that it is a vertical hyperbola. And it has nothing to do with the size of the denominators. We will still use a squared plus b squared equals c squared to get the c value. The center is still hk. Now this time, because this is a vertical hyperbola, and again, it is a vertical hyperbola because the y came first, has nothing to do with the size of the denominators. Also remember, whether we're talking ellipse or hyperbola, we are always letting a go underneath the x and b go underneath the y. So the vertical axis this time is your major axis. And to find the foci, we will take the c value and tack it onto the y part of the center. That's why this is k plus or minus c. To find the vertices, we're going to take b and tack it onto the y part of the center. That's why this is k plus or minus b, so that your foci and your vertices are of the same format. They both are h, comma, k plus or minus c for the foci, k plus or minus b for the vertices. And the slope of the asymptote still plus or minus b over a. So let's take a look at one with numbers. We first have to look at that equation. It is in standard form. Because the y is coming first here, we know that this is a vertical hyperbola. You need to be careful when you name things because this is in different order. Our center is what's with x, comma, what's with y. So our center is -1, comma, 2. Not 2, comma, -1. That's where you have to be careful with the vertical hyperbola. Also, a is underneath x, so a is 4. B is underneath y, so that's 2. To get c, we will do a squared plus b squared. So a squared is 4, because that's what that is. B squared is 16 equals 20. Take that square root and clean it up, is 2 radical 5. Now, we decided it was a vertical hyperbola. So let's go ahead and start graphing this. -1 up 2, there's our center. A is 4, so over 1, 2, 3, 4. 4 this way, 1, 2, 3, 4. B is 2, 1, 2, and 1, 2. And let's see if I can draw the box. Not very well. Oops. So there's the box, sort of. And our asymptotes are going to go right through center from corner to corner. It's hard to do with this tool. And because it is a vertical hyperbola, I know that it's going to come right down across the asymptotes, touching the vertex right there, bouncing off. Same thing here, hitting the vertex, bouncing off. Now I can name these things. The foci are located along the vertical axis, which is this x right here. So they're somewhere in this vicinity. Remember, they are outside of the curve there. So the foci, we take the c value and we're going to tack it onto the y part of the center because this is a vertical hyperbola. So our foci will be -1, comma, 2, plus or minus 2 radical 5. To find the vertices, because this is a vertical hyperbola, the b value will be tacked onto this. So this is negative 1, comma 2, plus or minus the b value, which is 2. Clean that up, doing the high road and low road if you want to think about it that way. 2 plus 2 is 4. 2 minus 2 is 0. And let's check that off the graph. Here's those vertices right there. And that is negative 1 up 4. That's that one right there. This is negative 1, 0. That's that one right there. The slope of the asymptotes is plus or minus b over a. So that's just simply 2 over 4. But that reduces to a half. The domain is from left to right. Now remember, for the hyperbola, if it is a vertical hyperbola, your domain is automatically the infinities. Your range coming in from the bottom is starting at negative infinity, going up to a height of 0, and then we've got a gap in there for the box, and it picks up again at 4 to infinity. Now you're being asked to write the standard form of the hyperbola and then name everything. And to do the standard form of this, we're going to have to complete the square like we did with the ellipse. But there is just something we got to be careful of because of the minus. So the first thing we want to do is reorganize this. We happen to have our x's right next to each other, which is great. I'm just kind of spreading this out a little bit. Minus 16y equals 43. So really I didn't need to move anything. Sometimes that number right there is over on the other side and you must change its side. We have to factor this out. So factor a 9 out of here gives us x squared minus 2x plus blank. We'll come back to that in a minute. Minus 4 times y squared. And if you factor a negative 4 out of this, this is going to turn into positive 4y plus blank equals the 43 that's already there plus a blank plus a blank. Then we have to actually complete the square. Half of 2 is 1, 1 squared is 1, but really we didn't just add 1, we added 9 times 1 to this value, so that's what has to be added over on the right side. Half of 4 is 2, squared is 4. Didn't just add a 4, we added negative 4 times 4, which is negative 16. That's a very important step that you get that straight, and that's really the only difference with the ellipse and the hyperbola versus what we did with the circle. Because we have coefficients, you have to remember to multiply by that coefficient. Furthermore, because this is a hyperbola, you've got to remember to multiply by negative 4, so that makes it a negative 16. So factoring up the left side, I have 9 times x minus 1 squared minus 4 times y plus 2 squared. Arithmetic over here makes a 36, and you know to be in standard form it has to be equal to 1. So I have to divide everything by 36 and then simplify my fractions. So 9 over 36, the 9 cancels, I get a 4. So I have x minus 1 squared over 4 minus 4 into 36 is 9, y plus 2 squared over 9, and 36 divided by 36 is 1. So that is my standard form. Lots of little places to make arithmetic mistakes, which will change these values down here. So be very careful with your completing the square and remember to multiply by the coefficient. Now, the next page is just that same form, just written up more neatly, and I've got room to do all this work. So what kind of hyperbola is this? Because the x is coming first, this is a horizontal hyperbola. Remember, it has nothing to do with the size of the denominator. Don't look at the 9 thinking that has anything to do with it. It does not. It is a horizontal hyperbola. So my center is 1 comma negative 2. Because it is a horizontal hyperbola, remember you're going to do things to the horizontal component of your center. So a is the square root of 4, which is 2. B is the square root of 9, which is 3. C is where I add those up. Gives me 13, but then remember to take the square root. So C is radical 13. Your foci are found by adding and subtracting that radical 13 to 1. Because it is a horizontal hyperbola, we are doing it to the horizontal component of the center. So the foci will be 1 plus or minus radical 13, comma negative 2, and that's all you have to do. Your vertices, because it's a horizontal, I'm going to take the a value and tack it on there, and that is 1 plus or minus 2, comma negative 2. I do need to do high road and low road. 1 plus 2 is 3, comma negative 2. 1 minus 2 is negative 1, negative 2. Now, on the last one, I happened to go to the graph sooner here. I did this arithmetic first. It doesn't matter. Do what you're comfortable with. For a lot of you, I think going to the graph right here is maybe a good idea. So your center is 1, negative 2. A is 2, so count over 2, over 2. B is 3, 1, 2, 3, 1, 2, 3. And let's use this and see if I can make a better box. Not too bad. That's off a little bit, but there's the box, sort of. And then my asymptotes go right through the center. Right through the center from corner to corner. Let's move this a little bit. There we go. So now back to vertices. Let's check this. This is a horizontal hyperbola. So it's going to be graph right in here, coming right to touch the vertex, coming right to touch the vertex. That should not have gone inside like that. That was just, I can't draw with this tool. So let's check about this. This is where the vertices are. We think it should be 3, negative 2 over 1, 2, 1, 2, 3 down 2. Bingo. And negative 1, negative 2 right there. Slope of the asymptotes, plus or minus b over a. So that's plus or minus 3 over 2. The domain, because this is a horizontal hyperbola, our domain is going to be from negative infinity up to this negative 1, union with, pick up after we get through the box, 3 to infinity. And your range, because it's a horizontal hyperbola, is automatically the infinities. Now, the next two problems are going to deal with equations. We have information and we want to come up with the equations. And I think, as we did with the ellipses, the best way to go is put whatever you can on the graph and decide, is it a horizontal hyperbola or vertical hyperbola? So it has a center of 1, 2. The focus is 6, 2, 2, 3, 4, 5, 6, 2. That's a focus. It has a vertex of 4, 2, 1, 2, 3, 4, 2. Now, that should tell you something. All that stuff is lined up along that horizontal line. That tells me this is a horizontal hyperbola. That means we're looking at this format, x minus h squared over a squared minus y minus k squared over b squared equals 1. And because I know the center, I know part of this answer already. The center is 1, 2. I'm just going to slip in a 1 right here and a 2 right here. I'll write this up neatly before it's all over with, but I know that. To be able to finish this, I have to come up with A and B. Well, the center was right here. The distance from the center to the vertex horizontally is our A value. All I have to do is count that on the graph to get from 1 out to 4. That's a distance of 3. We just found out what our A value was. The distance from the center out to the focus is the C value. So to get from 1 out to 6, C is 5. There's no way from this information right here to get B, but I do have a formula. The formula says for the hyperbola, a squared plus b squared equals c squared. So all I have to do is fill in 3 for A. I don't know B. Fill in 5 for C and solve. Subtract 9 from both sides is 16. Take the square root, and that means B is 4. So to write this up a little more neatly, we're looking at x minus 1 squared over a squared, so 3 squared is 9, minus y minus 2 squared over the b value squared, which is 16, equals 1. So coming up with that equation is really not that bad if you use the graph to get yourself started. Different set of information, write the equation of the hyperbola having center 0, 0, and y-intercepts 0, negative 4, 1, 2, 3, 4, 1, 2, 3, 4. And y-intercepts is a book way for saying the vertices. So as soon as you know that we have vertices here and here, that's telling me that this is a vertical hyperbola. And it has center 0, 0. So I know it's this format. Y squared over b squared minus x squared over a squared equals 1. So nothing fancy with a center. So this will stay y squared. This will stay x squared. I just have to come up with my a and my b. From the center to either of these vertices is a distance of 4. That is a vertical distance. That means B is 4. I don't know what A is. I don't know what C is, so I can't use A squared plus B squared equals C squared. But what I do know is that we've got these asymptotes at plus or minus 2x. That means the slope of this is plus or minus 2 over 1. Well, I'm just going to forget the plus or minus for a second and look at 2 over 1. Now, how do we get the slope? The slope is B over A. So I have this formula, 2 over 1, which is the slope of that equation, and B is 4. A we don't know. Solve that equation. You have 2A equals 4, so A is 2. And that's all I need to complete this equation. So A squared, 2 squared is 4. Now remember, A is going underneath x. B is going underneath y. 4 squared is 16. And that is the equation of that hyperbola.